Today, let's talk about spam checks and mechanisms for checking if a message is spam. This is a typical overview of common spam checking algorithms that are out there. So what types of mechanisms are there? Generally, even before your message comes in, somebody connects to you from another IP. So there are IP checks that you can perform. Then you can also do reverse DNS checks on the same IP that you got from the incoming server. After that, you can do message and header. Some spam filters, they do a message and header together as one, and some do it separately. You can check if the message is faulty, if the header is faulty, if there is a fake header or a message contains some spam words and so on. And obviously, if you didn't catch anything on the previous steps, you can catch it with artificial intelligence checks. Those are filters that can be taught how to catch and how to distinguish spam from not spam. So let's review IP checks. So IP checks are generally done by what is called RBL and DNSBL. So what is it? RBL stands for real-time blacklist. Some call it blacklist, some call it block list. It doesn't matter for our purposes. It's just a list of all the IP addresses that are, for one reason or another, blocked by this particular service. And there are lots of services on the market that do it. Services like Sorbs and lots of others, dynamic lists that change over time. Most of these lists, they employ sophisticated robots to find out if a particular server that they connect to is an open relay or a proxy and so on. So they basically blacklist all the open relays and all the proxies out there. Just the logic behind it is that if it's an open relay, spammers will eventually find it and will send spam through it. And DNSBL is DNS block list, but they're actually generally the same. It's just two different names for the same thing. And anytime you initiate a connection to the server or somebody initiates the connection to your server, it will check your IP against one or more real-time databases. That is almost always the case. I yet to find out about one provider that doesn't do it. Different lists, they obviously use different real-time block lists, but most of them do it. And obviously, each database that you use, they will have its own criteria for inclusion. So, for example, even within one organization, one and the same organization, like for example Sorbs, they have 5 or 6 different lists, and they include different items, different artifacts in this list. For example, one list may be open relays only, and another list may be open proxies, and so on. So how does RBL operate? Let's say you have a source SMTP server that wants to connect to your server, and the server connects to you. And obviously you notice the IP address from which it connects. Let's say it's, in this example, it's 123.21.15.12. This is the IP address of the source SMTP server. Now you actually want to formulate a request to Sorbs database, to one of them. There are many. And there's also an aggregate Sorbs list that includes all the lists. So let's say you want to question, is this IP blacklisted or not? So what do? So you formulate a request to their zone name. This is a general zone name, including all the lists, dnsbl.sorbs.net. So what you do is you reverse the IP that you got in the previous step. So remember, it was 123.21.15.12. So now you reverse it, 12.15.21.123, and you append the zone name dnsbl.source.net, and you send this request as a regular DNS request. So then what happens is, since it's a DNS request, it is sent to your local DNS. And your local DNS might know where dnsbl.source.net is, but it will not know where 12.15.21.123.dnsbl.source.net is, because it's a compound name. So it will send this request to what is called authoritative name server. And in this case, authoritative name server is located in SORBS. So it will check its database, will find out if this IP is blacklisted, and will just return you a status code. For example, let's say it goes back and sends you like an IP address that says the last digit of it is 1. That means that this IP is blacklisted. In some cases, if it's not blacklisted, it may send 0, and in some cases it will just not respond at all. Some servers do respond, some servers don't respond, but it depends on your implementation. And also, depending on the implementation, you can send additional TXT request. It's a different type of request to find out what the reason is. So, for example, if the server is blacklisted because it's an open relay, it will say something, this IP is open relay. Or typically what it does is gives you back a link to a SORBS website where you can actually find out details of why a particular IP has been blacklisted. And obviously, pros and cons of the RBL. There are good ones and bad ones, obviously. And the pros first. It's very quick to determine if an IP is a spammer. It's either yes or no, always. And it blocks about 80% of all the dumb spam when set up right. And by dumb spam, I mean there are lots and lots of spammers that are not really sophisticated. They just have an enormous database of a few billion emails that like 99% of them are dead, and they just spray and pray. They shoot these emails in millions, hoping that at least if you throw a ton of dirt against the wall, some of it will stick. But obviously 99.99999% of this is not going to stick, and it's going to be rejected and never delivered. And they use all the open relays they can find, all the proxies they can find, and obviously they know that 90% of those proxies are blocked anyway, but they still do it because they hope that maybe some administrator didn't block it and they will deliver at least some email, and some very tiny percentage of this email will buy the crappy product that they're selling. And one of the pros is it also conserves a lot of traffic, because a rejection will happen very, very soon. It will happen even before you got the entire message. So if, let's say, a message is 200 kilobyte, you will not even receive the message. You will not even receive the envelope. You will not get the SMTP exchange at all. You just get the IP address and reject it right away. And it's fairly easy to set up. Most of the modern servers, they have facilities for doing these DNS requests, and you just specify which lists you want to use. That's about it. And the list, one of the good and also sometimes you can call it bad things, is a list is maintained elsewhere. You don't maintain the list, so you don't control it. From one point of view, you obviously don't have to worry about it, but it's also one of the cons. You don't control it. That's it could be a double-edged sword. Now, the cons is some list managers are overzealous, and you have to watch out. They block just left and right. They just block everybody they can think of. And another con is you entrust part of your email management policy to somebody else. You don't control this part anymore. And obviously, in case the server fails, you will never know, because what will happen, your DNS requests will fail. That's about it. And also, you never know how good is this service. And there are some ways to find out, obviously, and there are tests being done on each and every provider. All the big providers, of course, but they're not extremely reliable. They're not very scientific, as you can say. Now we come to the reverse DNS checks. What is it? Again, remember we noticed the IP of the address that somebody connected to you, and this is a big reason why most of your checks happen with IP is to conserve traffic, because with busy servers, lots of messages, like for example, imagine the servers of Gmail or Yahoo.com. They got millions and millions and millions of emails per minute, per hour, per day. They have to be very conservative and have to work very quickly, and otherwise they just blow up the servers. They don't have the capacity to examine each and every single message that comes in, especially since 90% of it is spam anyway. So all the IP checks are done first. So when somebody connects to you, you obviously notice his IP, just like before. But then, according to the protocol, like SMTP protocol, the SMTP exchange starts. And you are required by SMTP protocol to say hello. And this is not hello with double L, it's hello with one L. It's not a mistake, it's actually spelled this way. Or what is called enhanced hello, eHello. And you're obligated to pass your domain name, your name. So a lot of servers, SMTP servers, will check what did you pass as your hello name, and will compare it to IP you pass. So let's say if you give me an IP, so I already know your IP because you connected to me, and now you are actually passing me your domain name. So I can resolve this domain name and compare it to IP that I just got. So if it matches, then I would say, yeah, maybe I will trust you more. If it doesn't match, then I will say, I either don't trust you at all, or I trust you less. So you pass something like ehello.mail.company.com, whatever. And now you have the IP address and domain name, and you can resolve the domain name and see if IP address you get is the same as the IP you got from the connection. And you can also do backwards. You can resolve the IP into domain. This is called reverse DNS resolve, or sometimes it's called PTR request. And you get the name from the IP address. You can also do it backwards. And not only that, some very sophisticated servers can do both. And just say, okay, if I convert the domain name to IP and convert the IP to domain name, and see if both of them match. Now we increase the complexity and we come to check the message itself. And there are lots of spam checks that check just the message, and there are lots of them that check message and header, the entire envelope, together with all the headers like your subject, your date, your received from, all the headers that are appended by other servers, and so on. So inside the message itself, when you actually get to the message, there are lots of stop words that spammers use. Like the lottery scams would use stuff like you won the lottery or something like that, or become a millionaire, or get rich quick, or something like that. Or if your relative died and left you, I don't know, $2 gazillion or something, and you are the sole heir to this $2 billion or whatever. So the stop words are hunted like crazy. And list of headers that can indicate fake mail client. For example, each mail client has a certain way of positioning the headers inside the message. So let's say you have an Outlook. It will always encode the message in such a way that there's first a text portion stripped out of HTML or any formatting like fonts and so on. And then after this, there is a MIME encoded HTML rich text message. And it's always like this. And obviously spam checks know it. So if they see that header that says, yes, I am Outlook Express, but the positions and the order of this headers do not correspond, they'll just say, okay, they say that they are Outlook Express, but they don't look like Outlook Express, so we will either reject it completely, or we will treat it as suspicious. And obviously, some filters, they block content like exe files or zip files. Some block any attachments. They can just say, okay, we don't accept any attachments. You can just send text or rich text HTML formatting. If you want to attach something, just send the link and attach it on the website. Our mail servers will not pass any exe files. For example, Gmail does it, and Yahoo does it. They don't accept any exe files and so on. And now we come to AI filters, the most sophisticated checks. Since we already filtered out most of the dumb spam, like I used to call it stupid spam, because any person who actually hopes to deliver something this way is pretty stupid, because he knows already that 99.9999% is going to be rejected. So now, after this dumb spam has been rejected by the previous filters, now we come to much less messages. And 99% of the messages were rejected by previous filters, and now the AI filters come into play. Filters that require training, they usually are AI filters. AI, artificial intelligence filters, almost always require training, meaning filters are trained by feeding them spam and ham content, spam and not spam, meaning let's say a filter classifies this message as spam. You as a human look at the message and say, yes, it is spam, or no, it is not spam, you classified it incorrectly. So then this is what is training all about. There are many types of complex filters that depend on fuzzy logic. Some of them depend on neural network. Some of them are expert systems like model-based reasoning systems and so on. Very complex stuff. And obviously there are pros and cons to it. I will not expand on this subject because there are so many of them, and there are different types, and there are types of, and they are very complex. So the pros, it will be pretty accurate after a lot of training by users. And what I mean by that is this filter is typically becomes very useful in large user environments. Like it's perfect for Gmail, for example. Gmail has millions of users, hundreds of millions of users, and at least some percentage of these users, they press the built-in buttons like this is spam or this is not spam. And each time you push this button, what you do is you actually train this filter to be more and more and more sophisticated. So imagine the cumulative effect of millions of users training this artificial intelligence filter. So it's very useful in this type of environments where you have a large corporation or a big provider that every user is allowed to train the filter. And this filter will filter out the last 5% of sophisticated spam. So all the spam that was not filtered out previously is going to be filtered out now. Now the cons are it's going to require expert setup. It's very complex. It's some of the filters you can spend days and days setting it up. It's not very simple. And obviously it's going to require a lot of training by the users. And it will not be very useful or even accurate if you just use the email occasionally and you are the only user of this email system with this particular filter. So if your database of training is not shared among the users, it's going to be very, very hard. It will take you thousands of messages to train the filter correctly. It just won't work. And most of the providers, they don't immediately, if they start something new, they never phase in the filters like this immediately. They kind of have the buttons that say this is spam and this is not spam. They classify the email, but the server doesn't react to it. It just builds and accumulates the database until it reaches a critical mass to be able to actually accurately test spam and not spam. And then, and only then, they actually roll out AI filters. But then it becomes very accurate. So here's the summary of most modern filters. How do they work? Most modern filters are a combination of the above filters. Almost none of them are actually a single filter. Like, for example, none of them include just the RBL. Most of them will include something else. And they use the above checks as weights or scores. This is a scoring system. Each filter that the message passes through, if it even passes through, is assigning a score from 0 to 100%. And then all the scores are summed up, and at the end, the decision is made if this message is going to score above a particular score. Like, for example, if the message is above 50% probability of spam, then it's going to be rejected. If it's, let's say, less than 30% but greater than 0, it's going to be accepted. And if it's between 30% and 50%, it's going to be sent to the spam box, like the spam box that you have in your regular email. Some messages are sent to the spam box, some are just, rejected outright. Most of them don't even reach the spam box. And obviously each filter is going to add or remove weight. Some of them actually remove weight. For example, if you have a list of contacts and this email, the from address of the email is in your actual contact list, then it's going to assign a negative score, meaning you know this person and his email is in your contact list. So it probably means that this is a legitimate correspondence. It's not going to say that this is 100% not spam. It's just going to assign a large score with a negative value. But if this message is still fake, then the positive score will weight more than the negative one. And obviously, after all the filters are executed, the system will obtain a final number. It's going to be 0 to 100 or, 0 to 10, doesn't matter, depending on the system. And it will make the decision.